Pearson's correlation coefficient, assumptions, hypothesis generation, and reporting the statistical analysis into a Word document or a dissertation or a publication paper. Assumptions for running Pearson product moment correlation. Those assumptions are set of criteria or conditions that have to be met before performing the Pearson correlation. Pearson correlation statistical test will evaluate the relationship between two variables and check whether these variables have a positive relationship or a negative relationship. So the value for the Pearson correlation ranges from -1 to 1. And to perform this statistical test, certain assumptions have to be met. The first assumption is that you will have two variables called pi-variate, and those variables have to be continuous, i.e. they are not ordinal or nominal variables. Ordinal variables are variables that have order in them, like 5 Likert scale or 7-point Likert scale, or an order such as first, second, third, and so on. For nominal variables are such as yes or no, male or female, occupation, professions, and so on. So to perform Pearson correlation, the first assumption that you should have a continuous variable, whether it's interval or ratio. The second assumption that have to be met before running the test is that your data has to be normally distributed. This can be examined and checked by drawing a histogram, which will show whether your data have a bell-shaped, normally distributed, or it has a flat curve or a pointy curve or a curve that shifts to the right or to the left. Also, a descriptive analysis of the data can determine the value for kurtosis or skewness. I've already made a video clip on the channel if you want to learn more about how to examine the normality of distribution for a data using a histogram. Another way to look at the normality of distribution is to produce a box plot. From the box plot, it will be possible to determine whether the data are normally distributed or not if the two whiskers are equal in length. And again, there is a video clip on the channels to follow. Another way to check whether the data are normally distributed is to draw a QQ plot and to find whether the data are aligned on the diagonal line or not. Again, there is another video for that. And finally, the normality of the data can be statistically checked using two available stat tests. The first one is Kolmogorov-Semenov test for normality, and the other one is Shapiro-Wilk test for normality. So those tests can determine the normality of the distribution based on statistics and based on the p-value generated. There are two available videos on the channel to watch. A third assumption is that you should not have any outliers in any of the variables. Outliers are an extreme high or low values or scores within your data set. The outliers can be visually examined and inspected using a box plot, using this formula to determine the values for these outliers. Another assumption that has to be met, that there should be a linear relationship between the two variables. And the way to examine that is to use scatter plot to draw one data on x-axis, the other data on the y-axis, and then look for linearity in the relationship. Another assumption is to meet also the independent of observation. That means each score in one variable is independent of the score in another variable. And another condition to meet before using the Pearson correlation is that your sample should be random and randomly selected from the population. Another assumption that you should not have any missing data in your variables. You have scores for both variables. And finally, another assumption that need to be met is the homogeneity of variances, and this can be checked using Levin's test. I've already produced a video clip describing Levin's test. So those are the main 8 assumptions. Pearson's correlation coefficient is one of the parametric statistical tests that can be used to evaluate and assess the relationship between two variables. Those two variables are parametric. And to determine whether the variables have a strong relationship, the direction of this relationship, and the value of this relationship, and the statistical significance relationship. The test is based on calculating the coefficient, which stands for R, Pearson's R. To perform the test, first of all, you need to generate a hypothesis, and I will show you how to write down the null hypothesis and the alternative hypothesis to perform this analysis using the Pearson correlation. And then once the test is run and an output is generated, I will show you how to write that output into a text format to be inserted into a document or into a dissertation or into a publication paper. For using a correlation between two variables, the null hypothesis states that there is no correlation between two variables. The correlation coefficient, abbreviated here as R, will equal to 0. The alternative hypothesis will state that correlation between two variables does exist, and so the R will not be equal to 0. So it will be either in the direction of the up to +1 or to -1. Once you perform the test, a p-value is generated. If it is less than 0.05, then that indicates significant value, and that will lead to accepting the alternative hypothesis. Again, the software will generate a value for the coefficient, which range from -1 to +1. In this next slide, I had inserted an output for correlation between two variables based on Pearson's correlation coefficient between weight and the calorie or calories consumed. And as we can see here from the table, the value for the R is calculated and is equal to 0.88. This is a high value, a positive value, indicate that weight and calories are related, correlate. There is a linear relationship between them. When there is an increase in the calorie consumed, there is an increase in the weight. So this is a positive relationship, and it's a strong relationship because it have a value of R close to 0.88. The correlation is significant, as we can see here. The p-value is less than 0.05, and the total number of the participants are 100 here, as shown by this table. And also the table has generated a bootstrap for 95% confident interval, such as the upper and the lower confidence interval. So how do we insert this into a text or into a Word document? The way to write that is to use the line below here, R, which stands for correlation between two bracket degree of freedom. Degree of freedom is calculated from n minus k. N is the total number of participants, k is the total number of variables. We have two variables here, calories and weight. So the value will be, for the degree of freedom, is 98. And then after that, an equal sign, you put the value for the R, which is 0.88, and then the lower 95% confident interval, which is 0.77, and the upper 95% confident interval, which is 0.98, and then followed by a comma, and then the p-value of p-value less than 0.001. How do we write this in a text format to place it in a document? We'll report that as a following. Pearson's correlation coefficient was calculated to evaluate the relationship between weight and calories consumed. The test has showed statistically significant positive correlation between the weight and the calories, comma, and then insert the findings from the statistical analysis that is obtained from this table. So this is the way to generate and write down the null hypothesis and alternative hypothesis when you intend to do correlation coefficient analysis based on Pearson's, and then how to write that into a text format to be placed into a dissertation or a publication paper.